I want to circle back to talk about elasticity, which we talked a bit about in the math review, but now that we have gone through consumer choice and talked a lot about demand and where it comes from, I want to remind you what calculation and interpretation of elasticity will look like in this context. So I want to start by finding the price elasticity of demand for Cobb-Douglas demand function. And I have a specific demand equation here, but what I'll show you is applicable to all Cobb-Douglas demand equations. So remember that for the interpretation of elasticity, we want to think about this percent change in quantity over percent change in price formula. How much does consumption change in response to a change in price? But for calculation, we want to rearrange that so that we have this equation, the partial derivative of demand with respect to price times price over quantity. So let's go ahead and calculate the price elasticity of demand for this specific example. And the first step will be, of course, to take the partial derivative with respect to price. So I'll just remind you that this equation here is the same as I over 4 times px to the negative 1. And that makes taking the derivative a bit simpler because, multiplying is easier than dividing always. So I've got negative 1 times I over 4 times px to the negative 2. So really what I have here is negative I over 4px squared. Now that is not my elasticity, right? That is just this term in my elasticity calculation. So to find the elasticity, I'm going to take this term and then I want to multiply by px over, in this case, x is my quantity. But instead of putting x in the denominator here, what I'm going to do, because x is really this fraction, is that I'm going to multiply by the inverse of x. Remember, when we divide by a fraction, it's the same as multiplying by the inverse of that fraction. So I'm going to say that's the same as 4px over I, right? That's the inverse, or 1 over x. Now, you'll probably notice right away that lots of stuff is canceling out here. Right, I've got my px, cancels out the square, the I with the I, and now I've got a 4px and a 4px. So everything canceled. And what I'm left with is an elasticity that's equal to negative 1. And this does not change with x or px or I. No matter what the value of our variables, the elasticity of a Cobb-Douglas demand function is always negative 1. This is called a constant elasticity of demand. The elasticity of demand does not change as consumption changes. So that's very unlike our linear demand curve where we had an elastic portion, an inelastic portion, and our unit elastic point at the middle. Here, demand is unit elastic at every point. Basically, with Cobb-Douglas, you're spending a fixed proportion of income on this product. So you'll notice if we rearranged our demand equation here to describe total revenue, recall that total revenue is equal to price times quantity, that's always a quarter of your income for this demand function. So there is no point necessarily where total revenue is maximized, or another way of saying that is that the total revenue is maximized at every point, right? The total revenue is the same at every point along the demand curve. It's a quarter of your income, regardless of what the price of X is. So this is true for all Cobb-Douglas demand equations. Of course, it's not true for all demand equations, right? Other types of demand are going to have other elasticity calculations that don't yield this constant elasticity of demand, but I think it is an important facet of Cobb-Douglas demand for you to be aware of. So then the next thing that I want to do with elasticity is to look at cross-price elasticities and just talk about what substitutes and complements look like in the context of consumer choice. Okay, so here what we have is a shift in prices for Y. So here you can see we have an increase in the price of Y, which shifts this budget constraint down, and that leads to a difference in the quantity of X that we consume, and of course the quantity of Y that we consume. Now, when we're thinking about cross-price elasticities, what we're trying to understand is how the price change for one product affects consumption of the other product. So here we want to know, how does this change in the price of Y affect consumption of good X? And you can see we've got this increase in price of Y, which of course leads to a decrease in consumption of Y. But it also leads to a decrease in consumption of X. So we would call these goods complements, because as you consume less Y, you will also prefer to consume less X. Now, if the opposite is true, if we have substitutes, then we're going to have some optimal choice equations that look like this. We have a similar increase in the price of Y, leading to a decrease in consumption of Y. But now in this case, our consumption of X is actually increasing. And so here you can see that as we consume less Y, we prefer to consume more X. We would call that relationship substitutes. And the cross-price elasticity is going to tell me what is happening to consumption of X as the price of Y changes. It will be negative for substitutes and positive for